Okay, I'm now back. It's Brent here. I'm now back with mini lecture 3 of the module 3 on local and place-based foods. So mini lecture 3 will focus in on environmental impacts of local foods. I'm going to share my screen again. Okay. So as I said, we have these assumptions, for example, the 100-mile diet authors about local food being better tasting, better for the environment, better for local economies, better for your health. Right now I'm going to focus as better for the environment. So why would local food be better for the environment? And the answer is it may be, but then again, in many cases, it's not. And that's what we want to get into in this section. So how would we decide kind of what was good or bad for the environment? Here are some measures that we can use. We can think about the environment in terms of food miles. So in that localized shelf label that I showed you, there was this food miles of 96 miles that the food had traveled from where it's produced to where it's consumed. We might just assume that the lower number of food miles, the lower the environmental impact. So if I grow tomatoes in my back garden, it will be better for the environment than if I get my tomatoes from someone around the corner or from a greenhouse in the outskirts of Edmonton or from Mexico, right? That the further the food has traveled, everything else equal, maybe that's how I should judge the environmental impact. Well, maybe. But maybe there are things about the way I'm producing my tomatoes that actually aren't so great for the environment. And maybe we should consider those things. Maybe I overwater. Maybe I am not very good with my fertilizer and pesticides. Maybe the cumulative effect of all of that is actually not so great. So we should think about that. So let's break this down. There are at least 5 measures that are commonly used. Sometimes we look at water use intensity. So how many liters of water are used, say, in an industry, or an easier way to compare how many liters are used for the kg of food. And that might be the kgs of food at the farm gate, or the kgs of food that are actually consumed by people, assuming that there's going to be waste and lost along the way. So we have to be careful about what we're looking at. So it might be the number of liters used. And if we think about livestock products, we might have to think about the amount of water which is used to produce the feed, which is used for the animal, not just the water that the animal drinks. So that's water use. We could also think about intensity of energy use. So like the kilojoules which are used, say by an industry in a particular area, or again, in intensity terms, in terms of kilojoules per kg of food. If we, as a unit, kind of a unitless measure, we can think about water quality impacts are important. So and there are 2 ways often that water quality is evaluated. We can do it by the emissions of pollutants into water, or so that end up into water, maybe air and then become water, or the level of pollutants in the water. So say the parts per million, or we could say the parts per million per kg of food. So this water quality might be fairly tricky. There are 3 different things we think about with water quality. Might be sedimentation, so we might raise the food in a way which causes a lot of soil erosion. Once it just detached from the soil, that eroded soil might move into waterways where it sediments things and also causes sedimentation of dams and other water storage devices. We might have runoff or discharge of inputs. So if we use excess levels of, say, phosphorus or nitrogen fertilizer, or we use too many pesticides or certain types of pesticides that might not all be used by the animal, by the growing plant, that might run off into waterways. There might be other pathogens, for example, bacteria from livestock operations or fungi, which also are a downstream negative externality of our food production practices. So we've got water, energy, water use, what sort of water quantity, water quality, energy. There might be biodiversity impacts, and we talked about this with Brenda a couple days ago, is the possibility of land being converted from natural systems that are good habitat for animals into agriculture uses, which are maybe good habitat for a few types of animals and birds, for example, but not very good habitats for many, many other types of animals. So, for example, when we convert tropical forests for production of soybean or palm oil, then there's lots of habitat loss, or habitat may be degraded for particular species that we pay particular attention to. For example, when certain types of pesticides are associated with bees and bee behaviors and ultimately to colony collapse disorder. Brenda also talked about degradation of habitat for the caribou that are very important, and she talked about the Bathurst caribou herd in Jasper Park. What often is used as sort of a catch-all these days in terms of impacts is actually greenhouse gas emissions, partly because we're particularly worried about greenhouse gas emissions these days as irreversible and are more global in their effect than many of these other things that we looked at here. So greenhouse gas emissions, these are gases which are released into the atmosphere, causing the greenhouse effect, so causing the effect of sun rays coming in, reflecting off the Earth's surface, and then come back up into the atmosphere where they are trapped or less likely to be released, and making the Earth warm as a result of that and causing other disruptions to the climate. So these are more and more and more of these greenhouse gases we release to the atmosphere. The more and more greenhouse effect we have, the more global warming, the greater the increased risk of climate disturbances like the big fires we've seen in Australia last year and the United States this year. How do we measure greenhouse gases? We measure them in terms of global warming potential. So not all gases have the same kind of reflectance properties that trap heat into around the Earth. So carbon dioxide we use as the most common greenhouse gas, and we give it a designation of 1. So a unit of carbon dioxide pollution has a global warming potential of 1. So we put that in CO2 equivalents. If we think about methane, which is produced by animals' digestive systems, especially cattle digestive systems, also produced by irrigated rice systems that trap gases in that are anaerobic systems. Those receive a weight of 21. So for every unit of methane, it's the same as 21 units of CO2. Nitrous oxide, which is released to the atmosphere when nitrogen fertilizer is applied to soil, and then the soil processes it with its biogeochemical processes. That has a global warming potential of 310. So 1 unit of nitrous oxide is equivalent to 310 units of CO2. Then things like certain types of refrigerants, like HCFC 23, a much higher greenhouse global warming potential, so 14,800, and those are used in things like refrigerants. So everything else equal, we would like to focus on things like refrigerants and then work our way down. But also carbon dioxide still, though it has a relatively low global warming potential, there's so much of it and so much released, we have to pay most attention to it. So back then, so this is, kind of a quick review of some of the things to think about the environmental impact of our food. Okay, so what does that leave us? Why would local food be better for the environment? Okay, it would be if everything else was equal and the differences really were about how far the food traveled, right? So that means there's things happening, say water use and energy use and global warming and greenhouse gas emissions associated with transportation of the food from where it's produced to consumed. If that was the main thing, then we would really be the main environmental impact of food production was its transportation, then we would be doing the right thing to focus on food miles. But there are lots of other differences that are meaningful in terms of all of these environmental effects like biodiversity, water quantity, water quality, energy, greenhouse gas emissions that are important and different between food produced in different places. So that if you want to make a good decision, you should consider all of those different factors. How do we do that, right? One thing we do is what we call a carbon footprint. So we might think of the greenhouse gases associated with a product. And if we're doing that, the best way to do that is to think about the whole life of the product. So the product comes alive during a production process. It lives part of its life on the farm. It's transported. It lives part of its life in processing. Then it's moved into wholesale and retail and purchase. Then it's used, and then it's disposed of. Right? So some products, and this is something which you can apply to any product, even a consumer product like a t-shirt or an electronics product, they have this life cycle, and it's good to think about the whole life cycle, right? So something that is very efficient in use, say my new furnace, that's an important part of it, but also I should still think about what went into producing my furnace and what's going to happen to my furnace when it's over, when it's done its useful life, and I have to dispose of it some way. Okay? So we think about life cycle. So we think about the lifespan of a product, and then we think about life cycle analysis. So this is an area which is somewhere between engineering and business and economics, often not taught in many university classes, but very important in the real world. So this is where we look at some environmental impact, and it can be measured in terms of water quantity, water quality, as I said before, or greenhouse gas emissions being a big one, where you say, what is the life cycle? So here's a very simple life cycle: production, use, and disposal, linked by those blue arrows. Coming into production that have greenhouse gas content are raw materials. There's greenhouse gases associated with the energy which is used in production. And then there's a product which moves on to use, and there's some leftover stuff. It can be solid waste, or it can be things which are released, like pollutants to air and water. So we've got those. We have to think about all four of those arrows: the raw material arrow, the energy arrow, the emissions to air and water, and the waste as the greenhouse gas associated with the production. Similarly to use, so often use is not very much on raw materials, but there might be tremendous amounts of energy, and there might be a lot of waste. And then next to disposal, and again, we look at these four elements of raw materials, energy, emissions to air and water, and waste. And many products have very high disposal costs, especially electronic products which are using, say, heavy metals, which are highly, are bad things for us to get into our environment. Next, so here's thinking about what this might look like if we were doing this for an agricultural product. We might think about, okay, what are the steps along the chain from raw product production to processing to transport to storage. What are all of the inputs which come and used in each of these 4 phases? And that then what are the emissions that are emitted along these different stages? So here's some of the things that you would be putting together if you were doing the audit of the life cycle analysis of a particular ag product, and could be anything. And then often we would stop there. We just look at the production side right to storage. If we thought that use and disposal was the same for everyone, right? So if we thought about almonds produced in a certain production system in Washington State compared to almonds produced in a different production system in Greece, we would consider all of these different ways the product got to the supermarket shelf, but what's on the supermarket shelf, we might safely assume that the use and disposal of those almonds will have similar effects. So that's one of the decisions you have to make with life cycle analysis. Here's a life cycle analysis report that was done in 2010 on beef production systems in Canada and published in the Journal of Agricultural Systems. So you can see there's the animal is born in the lower, sort of the middle with the cow-calf there. The animal moves into a feedlot at some point. Then it's moved through to as it's grown, then it's slaughtered, and it becomes beef on your supermarket shelf. Along the way, so as it's a young calf, it's producing both methane and nitrous oxide. It is consuming, when it gets, especially gets in the feedlots, it's not consuming just grass, it's consuming grain that comes from the farm, and the farm has its own CO2 kind of footprint. As the animal is in the feedlot, it's producing methane and nitrous oxide. Some of that is applied to the land, which works its way back in sometimes into the farm production system, and sometimes is an emission. So measuring all of that, you can come up with a greenhouse gas footprint for beef. And this is what it looks like. Is most of the greenhouse gases are methane emissions associated with the way that cattle digest food, which is in fermentation in their stomach. And that's different for cows compared to other types of livestock. So poultry and pigs have less of methane emissions because they have different types of digestive system. But for cattle, this is fundamental. About 5% of the emissions are manure, so less than 1/10 that from fermentation in the animal's stomach. So that's basically it's belches as it's digesting its food, and then you can see the other elements. So this is a big deal then for beef is how much is this fermentation and enteric methane. So if you're going to do a life cycle analysis, then you need to think about what are the links between production, use, the disposal chain that we're going to assess. We're going to just look at production, or we're going to have to carry it all the way through to use and disposal. How are we going to measure things? Are we going to say per unit of live weight, say for a cow, or per slaughter weight? We have to get that right. We have to be comparing apples and apples. Are we going to look at just greenhouse gas emissions, or is water use very important in this setting, or is energy use very important in this setting? And it depends upon kind of the reason you're doing this. And we have to think about what are we going to include? Are we going to include the trip by the consumer to pick up the product, which might be very important, say for direct marketed food in Alberta, or are we going to assume that someone makes a trip out to the countryside to buy beef from a farmer, that they would have made another trip for recreation that same day, and therefore you don't have to conclude it. So there's lots of decisions to be made, and we'll get back to this a bit later in the class. A company might want to do a life cycle analysis, so we're thinking about why promote local food. That you might want to promote local food if you do a life cycle analysis and you find that local food has lower, say, environmental footprint or greenhouse gas footprint than another one. A company involved in food production might want to do it because they want to make their operations more greenhouse gas efficient. They want to identify those things that cause the greatest amounts of emissions. They want to identify those which are easiest to change, things that are cheap to change. They want to figure out, well, if I made a certain investment to reduce my greenhouse gas footprint, what return will I get on that investment? They might have a system of kind of goals of continuous improvement. They might set benchmarks for monitoring and evaluating their improvement over time. They might just see that when they have emissions of greenhouse gases or other types of emissions, it's really waste, and their goal might be to reduce waste and therefore reduce cost. Or they may have to report their regulations to a variety of stakeholders in their business. And that some of the stakeholders include regulators. In Alberta, we regulate any business facility that generates more than 100,000 metric tons of CO2 equivalents per year. We might have shareholders, so they might want to maintain the commitment of the shareholders to their company and have a green image if shareholders are looking for that. They might want to be more responsible to their consumers, to be able to both in practice and in image, project a green image and an environmentally responsible image to their shareholders. Okay. This Gareth Edward Jones published this paper in 2012, then taking that life cycle analysis approach, pulling together all the information he could find at that time about the global warming impacts of local versus food sourced from elsewhere, and this was for UK consumers. So first thing was, what about transport? Because I said if you find that transport is really the main thing that's different about local versus more globally sourced foods, then you can just focus in on miles. But miles varies, right? Things which are sent by ship have very, very low greenhouse gas emissions associated with each kilometer that's on a ship. So you can see transoceanic freight has 0.01 kg of CO2 equivalent per ton per kilometer, where a van or a plane is going to be about 1.07 or 1.09 kgs of CO2 equivalent. So it depends what kind of form of transport you're using. Consumers are pretty relatively inefficient. You can see the cost per kilometer per passenger of driving a car. So if you're driving a car to kind of go and pick up your beef, then that's way less efficient than other forms of transport like the truck. So how important is that? So it depends kind of how it's being produced. So this looks at the energy use in megajoules per kg of apples, which are produced and available on UK market, UK shelves, looking at different elements from production through to consumption, at least through to the store. If you source something from New Zealand in different months of the year, so New Zealand, January, April, August, or October, if UK sources New Zealand apples, during each month, what are the elements of greenhouse of energy use which are associated with that versus sourcing from the European Union in different months. So you can see there overall, so in October, there's the total emissions from the European Union is 2.47. The total emissions associated with the New Zealand apple is 5.52. So in October, you're better sourcing from the European Union. But in other months, the difference is much closer. So in August, they're almost the same. August is 4.66 for the EU and 5.09 for the New Zealand, almost equivalent. So it depends, right? And this depends upon the storage costs, right? So we've got and then the only thing that's different here is this 2.90 cost of transporting by ship from New Zealand to UK is 2.9. That's almost canceled out in August by lower consumption, lower amounts of storage costs and lower cultivation costs. So almost everything else is lower in the UK, lower in New Zealand, but that's about balanced off by the difference in cost of transport. So here's analysis of tomatoes. So that was apples. This is tomatoes in the UK stores being sourced from the UK or from Spain. And you can see the primary energy is much, much lower in Spain. So is the global warming potential. The EP is eutrophication potential. So this is a measure of water pollution. And AP, which is acidification as an air pollution. So there's higher air pollution associated with the Spain tomatoes, also higher eutrophication potential, so higher water pollution, but it has much lower global warming potential. So you're going to choose on global warming potential, or you're going to choose on these other things. So it depends, right? It depends on what's most important in that area, what kind of trade-offs are the best for the area. So overall, so Edward Jones has done this for a whole variety of products, and his conclusion is that that you can't assume that local will have a lower carbon footprint than global. It depends, right? It depends on things like season, seasonality of production and consumption. So, so that season will depend, you'll figure out whether the product's been stored for a long time. If it's produced in a colder climate than a somewhat warmer climate, or climate in different parts of the world. Generally, for food products, the part of the whole production cycle from production through processing, through use, through disposal, the main part of the carbon footprint is in production. That isn't the way it is for many other types of products, like your t-shirt perhaps, but it is for food. So therefore, we need to pay a lot of attention to how the food is produced. Anything produced with greenhouses, whether it's in Edmonton or elsewhere, will generally have high carbon footprints if you have to warm the greenhouse with fossil fuel energy. There often are lots of ways that things that are good for reducing all manner of environmental impact are also great in reducing costs. And so there's lots of reasons why companies want to pay attention to doing life cycle analysis and really understanding these environmental impacts. Okay. Another set of statements, Edward Jones also looked at some of these other dimensions that I mentioned in my very first slide in mini lecture 1, that anything that's stated as an overall statement about nutrition quality, about superior nutrition quality of local food, cannot be substantiated in general. The environmental hazards of local food being less can't be supported in general. And that local food is healthier cannot be supported in general by the evidence. though there certainly are some examples of superior performance, but there are also examples where local food, it has worse environmental impact than the food we might source more globally. There may be local benefits from buying local in terms of economics, right? If you have you're sourcing from a farmer, the farmer is buying his or her food and other things in the local economy. There's maybe a greater multiplier impact. The problem is that the more we localize the economy, the less efficient the economy is. So there is always going to be a negative effect if we get more and more closer to closer kind of circles. We gain some things in economics, but we lose things. So, as someone who I worry about people in Kenya. If the UK stops bringing in snow peas from Kenya because of environmental effect, I know that might be good for the snow pea producers in Spain, but it's going to be terrible for the snow pea producers in Kenya, and that's one of the products that Kenya has a fair advantage to produce. So therefore, overall, we should all make our own decisions about local food, but we should become, if we want to do that for economic purposes or social purposes or environmental purposes, we need to do a bit more digging and not make general assumptions and think about this on a case-by-case basis. So I'm going to end third mini lecture here now, so I'll stop my share.